All right, this is on the exam review packet. I'm going to go through a bunch of this. I might not finish out every problem, but give you some idea how to do each one. The first one says ray EA and ray EG, and they want to know what angle they form. I forgot my G up here, I think. So EA is this ray, EG is this ray. They want to know all the different ways to name that angle, or they gave you a multiple choice there. So we'll just put the answer right here with the blank. Angle 2. Yeah, we could name that angle 2, so A is a possible answer. Then they say angle 3. Well, angle 3 is this angle over here, so that one won't work, so B won't work. Then angle GEB. GEB, that's that angle, so yes, that one works, that's C. Then angle GAE. GAE, that angle's not even really in the picture, so that won't work. Remember, the vertex has to be the center letter. And angle AEG. So yes, that will work, and that was letter E. So 3 of those answers will work. That's your answer to number 1. Number 2, they give us that picture. I'm not going to draw a picture, but they tell us that R is the midpoint. Well, if R is the midpoint, then segment PR has to be the same as segment RS. So we can just set up the equation. 7x minus 5 equals 4 times x plus 1. Over here we can distribute, get rid of that stuff. That gives us 7x minus 5 equals 4x plus 4. Subtract 4x on both sides. End up with 3x minus 5 equals 4. Add 5 to both sides. End up with 3x equals 9. Divide by 3. X equals 3. Make sure you go back and read the problem. It says, what is the length of segment RS? So we're trying to find the length of segment RS. Well, if we look back there, RS was this part. So in place of x, we're going to stick in 3. So it's 4 times 3 plus 1. Do that math, and that's going to give you the answer. Number 3. Says, what's the measure of segment QS? That's the whole thing. This is just using the segment addition postulate. So this is Q, that's R, that's S. This is 6.2 millimeters. And this is 15.7 millimeters. And we want the measure of the whole thing. So all we're going to do is take these two and add them together. So 15.7 plus 6.2. Add those two together, and that'll give you your answer. Number 4 says, which geometry term is modeled by a thumbtack on a bulletin board? So if this is my bulletin board, and I have that as my thumbtack, what are we dealing with there? And you can pick out the answer for that one. Number 5. Number 5, they give us this triangle. I graphed it already. And you could grab a piece of graph paper and graph it if you want. You don't really have to graph it. We had a rule that said if you're reflecting over the y-axis, then the rule said it goes xy goes to negative xy. All that happens when you're reflecting over the y-axis is the sign of every x coordinate changes. So if it was a negative, it becomes a positive. If it was a positive, it becomes a negative, and the y coordinates stay exactly what they were. If you graph it, then you could just count on the across the y-axis. So like here, G is 1, 2, 3, 4, 5 spaces from the y-axis. So that means it's going to be 5 spaces on the other side. 1, 2, 3, 4, 5. And that's going to be G prime. Ignore that extra mark. E is 2 spaces. So it's going to be 2 spaces over this way. And that's going to be E prime. F is 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be over this way, 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be F prime. And if you graph it, then all you'd have to do is find the coordinates of each of those. So G here would be 1, 2, 3, 4, 5. That'd be our X, and 1, 2, 3. And then you can find the coordinates of F prime and E prime and get your answer from that. Number 6, again, you could grab a piece of graph paper and graph this if you wanted to do it the graphical way. I'm going to do it using that formula to find the distance. The second distance formula that we learned, they give us the point 61 and the equation y equals negative 2x minus 2. Well, if we're going to use that formula, the first thing we got to do is this equation has to be in the form where it's ax plus by plus c equals 0. So everything's on one side and 0's on the other. So I got to add 2x to both sides. I get 2x plus y. These cancel out, equals a negative 2. And I add 2 to both sides. Can't put that 2 with the x's or the y's because they're not like terms, so it's just going to be 2x plus, I'm going to put a 1 in there for the y. 1y plus 2 equals 0. Now, once it's in that form, this 2 is our A, the 1 there is our B, that positive 2 is our C, this is our x1, this is our y1. The formula was this big long formula. It was A times x1 plus B times y1 plus C, all that, and that's in the absolute value, all that over A squared plus B squared in the square root. So now what we do is we just plug in everything and make sure you have out your calculator so you can do all this stuff. A was 2, so it's 2 times 6 plus B was 1 times y1, which was 1, plus C, which was 2, all that in absolute value, over A, which was 2, so 2 squared, plus B, which was 1, so 1 squared. On top, we do all that. 2 times 6 is 12. 1 times 1 is 1, plus 2, 12 plus 1 is 13, plus 2 is 15. So we got the absolute value of 15 over here. 2 squared is 4. 1 squared is 1, 4 plus 1 is 5, so we got the square root of 5. We end up with 15 over the square root of 5. Grab your calculator and you punch that in, 15 over the square root of 5, and it will give you the answer. Just round it off to like the nearest tenth or something, and it should give you the answer there. Number 7 says find the distance between A and B. Here we just have to use the original distance formula. A is -3, -4. B is 4, 5. The original distance formula looks like this. Subtract the x's here, square it, plus you subtract the y's here, square it. This is an x, that's a y, that's an x, that's a y. I'm going to turn these around when I stick them in. I'm going to put in 4 minus a negative 3 squared, just so I can do that little tick thing there, plus our y's are 5 and negative 4. So 5 minus a negative 4 squared. I can do that tick there again. I'm going to do a little bit of this. 4 plus 3 is 7. 7 squared is 49. Plus 5 plus 4 is 9. 9 squared is 81. Add those two, and it's going to give you something there. Then take the square root. And actually, it looks like on the answers, you might not have to take the square root there, but that'll give you your answer. Number 8. They give you this. They say these are pins. You got a pin at C, you got a pin at E, you got a pin at D. And it says, how much string is needed to reach from pin E? So we're starting here. We're going to D, and it seems like we're wrapping around it and then going back to C. So we want this distance, we want how much string all of that is. We want this distance, which is 2.7, plus we want that distance again, another 2.7, plus we want the distance from E to C, which is 1.1. We're just going to add all those up, and that should give you your answer. And your answer would be in inches. Number 9, we could graph number 9. I'm not going to. They give us the points for A and B, and N is negative 3, 4. T is 7, 6. We want first the distance, so we're just going to use this. That's an x, that's a y, that's an x, that's a y. Our x's are 7 and negative 3. I just turned them around so I can do that little tick there. And then 6 and 4 are y's. 7 plus 3 is 10. 10 squared is 100. 6 minus 4 is 2. 2 squared is 4. Add those two together, you get 104. I'm not going to do the answer for you. You can grab your calculator and whatever the square root of 104 is, that's the length. And for part B, they wanted the midpoint. Midpoint formula is just this. You add the x's together, divide by 2. Add the y's together, divide by 2. So we got our x's are 7 plus a negative 3 divided by 2, and our y's are 6 plus 4 divided by 2. 7 plus a negative 3 is 4 divided by 2. 6 plus 4 is 10. We're going to divide that by 2. Remember, you should get 2 answers here for a midpoint. I'm going to let you do the division and fill in your 2 answers there for x and y. Number 11. Or I'm sorry, number 10. They give us a rectangular prism. And this rectangular prism, this edge is 12, this edge is 8, and this is 6. We'll do the volume first. That's the second answer, but we'll do it first because it's easier. Formula for volume of a rectangular prism is length times width times height. So all you got to do on that one is 12, that's a 12, times 8 times 6. Whatever you get there, and your answers have to be in inches cubed. So you punch that into your calculator and you fill in your answer there. That's for volume. That's actually the second answer. Now for surface area, there is a formula, but we don't use the formula. What we do for surface areas, we just find the area of each face separately and add them all up. Well, rectangular prism has 6 faces. The front face has dimensions of 12 and 6. So we'll say 12 by 6. The back face is going to be the same, 12 by 6. This side face over here is 8 by 6. And that means the other end is also 8 by 6. And then the bottom is 12 by 8. And that means the top has to be 12 by 8. 6 times 12 is 72, so the area of that face is 72. The area of this face is 72. 6 times 8 is 48. That's 48 also. 8 times 12 is 96. That one's 96. And all we're going to do is add all of those answers up. So you can do that on your calculator, add them all up, and that's going to give you your surface area equals whatever you come up with, and your units are going to be inches squared. Inches squared. Number 11, they want us to find the distance between these two lines. Y equals negative 2x plus 5, and y equals negative 2x minus 5. I'm going to graph these instead of using that other formula. I'm going to graph them and do it that way. To graph this first one, again, remember you start at the y-intercept, which is right there. So we go up 1, 2, 3, 4, 5, put a dot. This slope is negative 2 over 1. That tells us go down 2 and to the right 1. Down 2 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 to the right 1. Or I could go up 2 to the left 1. Up 2 to the left 1. So our first line looks something like that. Our second line, we start right there at negative 5. 1, 2, 3, 4, 5. The slope this time, same thing, negative 2 over 1, ignore that. So that tells us go down 2 to the right 1 still, but we're running out of space, so up 2 to the left 1, 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 so on, so on. So our line looks something like that. Now what we want is we want the distance. Well, to find that distance, we have to find the slope of the line that's perpendicular to both of them. So that slope is going to be the opposite reciprocal of the original slope, which was negative 2 over 1. So we flip it over, and since this one was a negative, we make it a positive. So the slope's going to be, we flip it over, and it becomes a positive. So now it's telling us to go up 1 and to the right 2. I pick any point that I want on one of these two lines. I'm going to pick this point right here because it looks pretty easy. It has coordinates of negative 3, 1. And I want to go up 1 and to the right 2. Up 1 to the right 2. And notice I hit the line right there at that point. So that's where it's going to be perpendicular to the two lines. And I find the coordinates of this point, which is over 1 to the right 1 and up 3. And all I'm going to do is use those 2 points and the distance formula. That's an x, that's a y, that's an x, that's a y. So now I'll come back over here and I'm going to use the distance formula, the original distance formula. The x's are 1 and negative 3, so 1 minus a negative 3. I can do the tick-tick thing there again. And then 3 and 1 for the y's. Do a little bit of math. 1 plus 3 is 4. 4 squared is 16. 3 minus 1 is 2. 2 squared is 4. Add those together, you get 20. Find the square root of 20, and that will be your answer. you can do that part on your own. Next one, number 12. They give you a picture, it looks like this. Tell you that angle's 90. They tell us angle AEB, which is right here, is 37. Well, we know all these angles together should add up to 180. So we can just take 90 plus 37. Add those two together, get that answer, and then you're going to subtract that answer from 180, and that's going to be your answer. So add those two, take that answer, subtract it from 180, and that's going to be how big that angle right there is. Number 13, they give us a picture, it looks like this. My picture might not look the greatest. That's 54 degrees, and this is 4x plus 34 degrees. And they want us to find the value of x. Well, these two angles are vertical angles, so they have to be congruent. So 4x plus 34 has to equal 54. You solve that equation, and that's going to tell you what x is, and that's the answer they wanted. So you just solve that equation, and that'll be your answer. Number 14, they just want you to find two segments on that number line that are congruent, so the same length. So I'm going to tell you the first one. That's AC, segment AC, and you're going to have to pick out what it's congruent to, segment what, and just fill in the blank there. Segment AC is 3 units long. What other segment on that picture is 3 units long? Number 15, another one of the distance problems. I'm going to use the formula. Again, you could graph them and do it that way. They say find the distance from point 26 to the line x plus y equals 4. Well, if I'm going to use the formula, first thing I got to do is I got to move this 4 to the other side. So I'm going to subtract 4 on both sides, so I get x plus y minus 4 equals 0. Put a 1 here, a 1 there. That's our A. That's our B. And that's our C. This is our x1. That's our y1. Now I'm just plugging into that second distance formula. Absolute value A is 1 times x1, which is 2, plus B, which is 1, times y1, which is 6, plus C, which is actually going to be minus 4. All that in absolute value. A squared, that's 1, so A is 1, so 1 squared. B is 1, so that's 1 squared. When I do all this, that's 2, that's 6, so 2 plus 6 is 8. 8 minus 4 is 4, and the absolute value of 4 is just 4. On bottom, 1 squared is 1. 1 squared is 1, so that'd just be the square root of 2. Figure out, grab your calculator, and whatever 4 divided by the square root of 2 is, just round it off. That's going to be your distance. On problem 15. We could use the graph. We could graph all that stuff. If I put problem 15 on here twice, just skip over it. I apologize, I just forget. So we have that. I'm going to use the formula. If I use the formula to solve this, I need to move this 4 to the other side on this equation. So I got 1x plus 1y minus 4 equals 0. This is my A, that 1 right there. Ignore all those stray marks. That's my B. That's my C. This is x1, this is y1. Find the distance again from this point to that line. I could use the graph and do all this stuff, but this time I just think it's easier to use the formula. A is 1 times x1 is 2, b is 1, y2 is 6, and c is -4 or -4 there. That's all inside the absolute value symbol. On the bottom, a is 1, so 1 squared, b is 1 squared. Does seem like I did this problem. 1 times 2 is 2, that's 6, that's 4. 2 plus 6 is 8. 8 minus 4 is 4. Absolute value of 4 on top is just 4. On bottom, 1 squared is 1, 1 squared is 1, 1 plus 1 is 2. Grab your calculator, take 4 divided by the square root of 2. That's going to give you your answer. You can do that part on your own. Number 16. They give us a picture. I'm not drawing the lighthouse and everything else. They give us a picture. It looks like this. Wow, look, it looks like a Z. They tell us that this is angle 1, this is angle 2, and they tell us that angle 2 is... Teacher's part. They tell us angle 2 here is 55 degrees. Well, if these two lines are parallel, then that means these are alternate interior angles, and they have to be congruent. So the measure of angle 1 has to be 55 degrees. Number 17. On number 17, it says name 2 lines. I'm going to name one, and you can name the other one. Remember, a line, you got to use 2 letters. So I'm just going to pick the line that goes through the 2 planes there on the right-hand side, and ignore that, X, Y, and you have to use the line symbol above it. So that's one of them. You can do the second one. 2 letters, 2 capital letters, and the line symbol. Rays, you could use that same thing as a ray. Say it starts at X and goes through Y, and then use that ray symbol. Then you can name the other ray yourself. Again, a ray, 2 letters, and the ray symbol. C says, name the intersection of the 2 planes, plane M and plane N. 2 planes always intersect at a line. So I'm going to give you the line symbol there, and you can name the line. It's the line where the 2 intersect. I'll just tell you, it's line UZ. D, name 3 collinear points. I'll give you 2 of them. There's different ones you could name here, but collinear just means on the same line. I'm going to say point A, point Z, and then you can come up with the third one on your own. Number 18, they give us a picture. It looks like this. I forgot to put this letter in here. I told most of you in class, but some of you didn't get a chance to, so put that letter in there, that L. First one, they want a right angle, so letter A. A right angle would be angle NLT. B says name 2 complementary angles. Complementary angles are 2 angles that add up to 90 degrees. Well, we look right here, that's a right angle, so these 2 angles have to add up to 90 degrees. So I'm going to give you the first one. First one is NL, angle N. LB, make sure you're using your symbols, and then you can name the other one. Letter C says supplementary angles. Could be a linear pair, two angles that add up to 180. I'm going to use this one right here. We'll use these two angles. So this first angle is angle SLH. And then you can name the other angle. Number 19, they give us a picture, it looks like this. They tell us this angle is 40 degrees. They tell us that these two lines are parallel. This is our transversal. You should be able to find all the rest of these angles. We went over this in class. I'm going to give you some of them. You can find the others. These two angles together should have to add up to 180. So you can find that, just 180 minus 40, and come up with that. This angle over here is vertical to that, so that has to be 40. This angle and this angle are alternate interior, so that has to be 40. This angle and this angle, previous, next. This angle and this angle are corresponding angles, so that has to be 40. And then you can, whatever you get here is going to fill in these other four angles. Number 20, they give us a picture, it looks like this. They tell us these two lines are parallel. Got this, we got this. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 16, and 15. And they tell us angle 1 is 70 degrees, so I'm going to write that in there. And they tell us that angle 14 is 105. Now, the first thing you should do, I'm going to separate off our two parallel lines, and I'm going to use this as our transversal. So this is 70, and you can transfer all this back into there. These two are parallel. That's 70, that means that's got to be 70. It means this one over here has got to be 70. It means that one's got to be 70. To find these others, we subtract from 180. So 180 minus 70 is 110. That's 110, that's 110, that's 110. So that gives us all these angles. Then if I separate off the two parallel lines and use this bottom as my transversal, they tell us this angle is 105. Means this angle's got to be 105. This angle over here has to be 105. This angle has to be 105. 180 minus 105 is going to give us these other four angles. So you can fill those in. Once you get all that done, you can take both these and fill in all your answers. Problem 21. They give us a picture, it looks like this. Got to write a two-column proof. That's angle 1, that's angle 2, that's angle 3, that's angle 4. The given information says angle 1 is congruent to angle 3. We know angle 1 and angle 2 are congruent because they are vertical angles. So somewhere in our two-column proof, we're going to have something about vertical angles. Then if 1 and 2 are congruent, 1 and 3 are congruent, that means 2 and 3 are congruent. And we can find that by substitution. We know 3 and 4 are congruent because they're vertical angles. And if angle 3 is the same as angle 4, and angle 3 is the same as angle 2, then that means 2 and 4 have to be congruent by substitution. That's what we're trying to prove. We've got our statements, we've got our reasons. First statement, angle 1 is congruent to angle 3. That was given to us. Number 2, angle 1 is congruent to angle 2. A reason, vertical angles are congruent. Then I look here, I got one here, so that means angle 3 and angle 2 have to be congruent. And that's by substitution property. And number 4, I know angle 3 has to be congruent to angle 4. Ignore that, and that's because they are vertical angles. So vertical angles are congruent. I got 3 here, I got 3 here. That tells me these other two have to be the same, so angle 2 is congruent to angle 4, and that's what I'm trying to prove. And all I used there was substitution property.